in this lecture, we will talk about definition of reference angles. Okay. Now, first, let's understand what's the meaning for reference angles. If theta is a no quadrantal angle, means the terminal side is not either y-axis or x-axis. Recall the definition. So, if theta is a no quadrantal angle with terminal side L, means the initial side is neither on x nor on y axis. That's like that. They are not on the any axis. Okay. So then the reference angle of theta is the acute angle formed by L and the x-axis. So that's actually between L, terminal side, and x. You see, if L is right here, then the reference angle is just simply this one, because between L and x. And it has to be an acute angle, so less than 90 degrees. If x is in the second quadrant, the terminal side is in the second quadrant, then the acute angle between L, this is L, okay, and x would be this one. So if the angle is in the second quadrant, then the angle theta is actually pi minus this angle. Okay? Alright. Now, I like to draw this dotted line to find out another angle which is equal to this reference angle. Okay. Now, that's in second quadrant. In the third quadrant, theta is from here to here. What's the reference angle? Terminal side is down in third quadrant, L. Then between L and x-axis is this acute angle. So this acute angle is called reference angle. Okay. Again, I like to extend this line to the first quadrant. And then you can see that this angle theta is actually equals this angle. This angle equals this one, reference angle. So reference angle plus pi, you will get theta. So in the third quadrant, if the angle theta is in the third quadrant, then you will have a reference angle plus pi. If it's in the second quadrant, you will have a reference angle equal pi minus reference angle. You can see here this one equals this one, reference angle. Okay. Now, if the angle theta goes in this way, that's in the fourth quadrant. L here is in the fourth quadrant. If the angle is in the fourth quadrant, then between L and x-axis, the angle is an acute angle formed by L and x. So L and x. So this is the reference angle. Okay. Again, I like to mark the angle which is equal to the reference angle in the first quadrant. Okay. How did we actually get this angle? You can look like in this way. Rotate first 360 degrees, that's pi. and then rotate back. So minus theta r. Okay, so it's like 2 pi minus the reference angle. You will have the theta. Okay, so this would be theta, the original angle. Okay, why do we need to study the reference angle? You probably remember the previous lecture. You see, when the angle, original angle was t, if they rotate 180 degrees, then there is a relationship between the original angle t and the angle you rotated 180 degrees more. You put negative in front of it. For the original angle, negative sine t equals that. You have the value of the, after you rotate it, this value sine pi plus t. So the reason is that we actually wanted to use the acute angle, the values of the trigonometry functions for the acute angle to calculate no acute values of the acute angle. That's the purpose. Okay? So step 1 is that we need to find out the acute angle first. And then the acute angle is basically called the reference angle. So we need to find the reference angle, and then we apply our formula. That's the main purpose. Okay? So here are the steps. And again, is that I wrote for your notes is that why do we need to find out the reference angles? The reason is that values of trigonometric functions with angles in quadrant other than the first quadrant can be calculated by finding the values of their reference angles. Yeah, and then you assign the proper sign to the values for the reference angle, for the acute angles. You will get the values for the trigonometry functions with angles not in the first quadrant. That's the main purpose. And here is the step. There are 2 steps to find out the reference angle of a given angle. Here are the steps. Step 1 is that if you are given an angle alpha which has the same terminal side with a given theta, then you know this is the necessary step. Okay, I will show you what's the meaning for that. Sometimes if you are given negative, maybe let's say negative 120 degrees, you want to figure out where this quadrant is, which quadrant this angle is in. So you want to do is that find out the alpha. Alpha has the same terminal side with theta, but this alpha has to be between 0 and 2 pi. Okay, that's the point for this. You are given a theta, you want to find the alpha, which has the same terminal side, but alpha is in between 0 and 2 pi, or is in between 0 and 360 degrees. Because for the alpha is in 0 and 60 degrees, is easy for us to handle. If is it between 0 and 90, we know is in the first quadrant. If it is between 90 and 180, we know is in the second. And if it's in the between 180 and 270, we know is in the third. And if it's between 270 and 360, we know that's in the fourth. Okay, that's the step 1. We want to locate the corresponding angle alpha, which is a positive, but less than 2 pi or less than 360. Then you know if it's in the first quadrant, then we don't need to work on that. If it's in the second quadrant, we know that's pi minus theta r. You see, second quadrant, pi minus theta r. If it's in the third quadrant, that's pi plus reference angle. Okay. If it's in the fourth quadrant, that's 2 pi minus reference angle down here. Okay? So there are two steps. Now let's look at the applications.